Hi everyone, we are from Group 80 and for our final project we chose the LLM Detect AI Generated Text competition. So some information about the competition. The objective here is to develop a model or algorithm that is capable of differentiating AI generated versus student written essays. The dataset provided here, the first one is the essay dataset containing the text itself and the prompt used to generate the text and the label itself, whether it is generated by AI or human. And then there's a prompt data set which contains the list of prompts used to create the text. This is what the dataset looks like. So the first one is the essay dataset containing the text, and then the prompt used to create the text and the label. And then the prompt dataset here contains the prompt name and instructions given to the people who created the text. And after doing some observations, some highlighted findings here is that the data given by the competition here is very small, which is only around 1,300 rows with only 3 rows of the positive class. And most solutions involve adding more data for training the models. And the top ranked solutions usually uses an ensemble of models combining large language models like Mistral, Llama, or GPD and pre-trained models like Deberta or Roberta. Here's the dataset provided in the competition, which contains only 1,300 rows. And as you can see, the positive class only a very small proportion here, only 3 rows, which is only around 0.2%. And some of the most used datasets containing AI generated versus human written text data compiled from different sources are the DAIGD V2 dataset and the human versus LLM text corpus dataset. This is a label distribution of these two datasets, and we can see that in these two datasets there are a lot of AI generated text, so it can help our model learn better. And also, the dataset sources will be included in the appendix of this report. And then more information about the external datasets. On most of the external data used, the AI generated text typically consists of essays generated by LLMs like Llama, Cloud, etc. And for the human text, these two datasets are the mostly used. The first one is the Parachute Corpus 2.0, which contains 25,000 argumentative essays produced by 6 to 12th grade students for 15 prompts. And the second one is the Slim Pajama dataset, which is a filtered version of Red Pajama. And it is a deduplicated multi-corpora open source dataset used for training LLMs.
Now for our approach. So most of the top solution in this competition are an ensemble of various model, and below we list some of the most used model in this competition, sorted by the performance. The first model or the first type is LLM models, which include Mistral, Llama, GPT, Cloud, and etc. And this LLM model is the most used one in this competition, and in overall they yield the highest performance. Second, we have a pre-trained model, mostly from the bird family. This consists of Deberta, Roberta, and much more. Then we have also a bidirectional LSTM model combined with a transformer CNN model. And this model is also some people use it, but in terms of performance, they rank 3 based on our finding. And lastly, there is also some code that use TF-IDF model, but overall this yields the lowest performance. Let's talk about LLMs. So the main advantage of using LLMs that we can directly use it for inference, meaning that we don't need to do any additional training. And this means that LLMs offer the best performance for its size, hence why we put it in top of performance compared to the other method. But alternatively, we can do fine tuning or we can do prompting to obtain a better result for LLMs. And usually, this is how people implement their code in this competition. For fine tuning, it have a much higher potential performance, but usually this come with a cost that we require much higher computational cost and time limitation. While if you do prompting, the performance usually depends on the prompt quality itself, but it is easier and faster to implement for the code. For the second method, we can do pre-trained model. And in this model, much like the other people, we will use bird model from the bird family. And the bird model from the Kaggle one is all already pre-trained on fairly large corpus, meaning that they should already have a strong understanding of the text at hand and could yield a good performance while doing this text. And so what most people did for when they use BERT is that they just add an additional on an extra output layer to classify the AI versus human text. And then they will do a further fine tuning for the model with the extra layer.
So for the next one, we looked into a bidirectional LSTM and transformer CNN. Here they utilize a LSTM, transformer, and CNN models. Here they use a bidirectional LSTM because they needed to compute the forward and backward pass, and then the output of this LSTM will then be passed to through the transformer to capture a more complex relations. And then lastly, the output of the transformer itself is then fed into a convolutional layer to extract more relations. Lastly, we looked into the TF-IDF approach because we saw that some people also utilize the uh, classical machine learning approaches by building a TF-IDF matrix out of the corpus and then feeding it into a classical machine learning model, such as random forest, boosted trees, or naive Bayes. And then while these methods couldn't achieve the same level of performance as advanced models or the previous approaches, this is still very interesting because these methods show that meaningful results can still be obtained with relatively limited computational resources.
Now let's talk about our progress and some of the challenges that we face. First, we have tried creating our own code to perform this AI versus human generated text by first doing a fine tuning on the Delta model, and second, we also did some prompting on the Mistral model. But unfortunately, while doing this, we encountered some issue, that is memory error. So we haven't been able to successfully make submission yet in this matter. Second, uh, when doing training for the fine tuning of an LLM model with a very large dataset, we consider this option to be difficult for our situation since our computing power is limited while when we compare this to the gold medalists in the leaderboard. Because from our finding, we found out that for the gold medalists, they have their own set of computing power that they do locally. So to do this option, we might need to consider this restriction for our situation. And lastly, we also have studied or referenced that we need a very large number of dataset in order to perform best or like to perform with a competitive result in this competition because we found out that most of the gold medalists they have their own like personal dataset and they also like include some of the external dataset that have a fairly large size. For example, they have like a 1 million size of data. And this is also the challenge that we might need to consider when we need to do our code or to perform this task.
So here are the future plans that we have come up with after doing the research. First, we will try to train an LLM with a large data set to see how possible it is depending on our computing power and fine tune it. Maybe we can try something like combining the top data sets used by the um, top results from this competition and then maybe use that as our training data sets and also for testing, and then we will then use the above methods, the methods mentioned before, to do our experiments out of their results. And maybe we can make an ensemble out of the best performing models to get one final result. And then we can also explore other methods, for example, like data preprocessing or feature extraction methods that has been proposed by other solutions and discussions, so on.
Additionally, here we will list out our resource that we found in the appendix. Here is the list of resource regarding the DAI GT data source that we found out throughout finding. And here is the list of resource regarding the LLMs versus human data source that we find. So that's all for our presentation. Thank you for listening.